Hi, in this video we're going to look at the topic of percentage change, which is a GCSE Higher and Foundation topic. As ever, if you want more information you can contact me on Twitter at Mr_G_Walton, or to follow the school account it's at Tupton Maths. So in this particular video we're going to look at using the idea of something called a multiplier. This is going to be really important in being able to do these percentage increase and decrease problems. We might also look at some repeated percentage change, so for example compound interest, where we increase something and it gets bigger, or depreciation, which is a percentage decrease or over a number of years, and the answer is going to get smaller. And we're also going to look at being able to calculate the value before a percentage increase or decrease has been applied, and this is known as reverse percentages. Okay, first of all, let's start off and just have a look at a very basic example, and let's see what happens from here. So it says a holiday costs £6,400 and the price is reduced by 8%. Calculate the reduced price of the holiday. Now, it might be that this is a non-calculator paper, and if it is, I'd go through the normal way of saying find out what 10% is, find out 5% and 1%, and so on, and we can get the answer that way. So I'm just going to do that, but I'm going to do it to the side because most of this video is going to involve using our calculator. So this may be just a good quick reminder of how we would do it if it's non-calculator, and then I'll show you a very quick way to do it using our calculator, and we'll compare our answers. So if we worked out what 10% was first, that's dividing by 10, so 10% would give me £640. If I had 5%, that's half of that, so that's 320. And if I had 1%, that'd be £64. So I've got another 1%. I'm trying to make 8% here out of a 5 and 3 ones. Another 64. And then I can add this section here and get a final total, which is going to give me, let's see, £512. Okay, so £512 is the amount that I'm going to reduce the holiday by. So I'd get 6,400 minus 512, and again I can do this either using a written method, or I'm actually just using my calculator here, but we're aiming for this value, 5888. Now on a non-calculator paper there's lots of areas where you can make a mistake. You can make numerical errors here, you could add up incorrectly, and most importantly you could forget to take that away from the original amount. It's very easy after you've done a lot of maths here to think, right, I've got an answer, job done. But that's not actually the answer. The answer, obviously, we need to reduce by 8%. This is just what 8% is. Okay, let's see if we were going to do it a different way, how we might go about it. And this time I'm going to use something called a multiplier. Now, if I was multiplying 6,400 by 1.00, I'm going to end up with 6,400. Okay, fair enough. Now, I want to reduce by 8%. Now, 8% is the same as 8 hundredths. So I want to reduce by 8 hundredths. Now, again, thinking about this logically, this is my hundredths column, so I'm reducing this multiplier by 8. And in fact, what I'm going to end up multiplying by, 6400 multiplied by 0.92. Notice what's happened here is I've reduced my whole one, the multiplier, by 8 hundredths. Okay, so I'm multiplying by 0.92. I'll do that on my calculator. 6400 multiplied by 0.92, and I get 5888. Now, it's exactly the same answer as what we got before, but much less in terms of calculation. And this idea of a multiplier is really, really powerful one. If you can get the idea of it and you can get used to it, brilliant. Okay, let's move on to the next example. In this one, it says on March the 1st, 2005, a house was valued at 13% more than on March 1st, 2004. So a year before. So basically what it's saying so far is that in the first year, between 2004 and 2005, the house has increased in value by 13%. Okay. On March the 1st, 2006, so that's a year later, the house has been valued at 8% more than on March the 1st, 2005. Okay, now it then says percentage increase over the 2-year period is not 21%. Calculate the actual percentage increase and show your method. Okay, now this is a really, really important thing because on the face of it, you'd think, well, 13%, add on 8%, gives you 21%. And we'll show you how you would go about this here. Now, it doesn't actually matter what kind of values you use for your house. Percentage just means per 100. So why don't we start off and just say let the house at the beginning, so that's on the 1st of March 2004, be, and let's make it easy for ourselves, let's make it £100. Okay, so we're going to take that £100. Now we're going to increase it by 13%. So we've got 100 and we're going to multiply it by our multiplier. Now, last time I said I'm going to start off at 1.00 and I'm going to add on, in this case, 13%. So what I'm actually going to add on is 1, 3 here. This is my multiplier. Okay, so I've got 13 hundredths that I'm adding on. Here we go, 13 hundredths. I'll do this on my calculator. So 100 multiplied by 1.13. I really shouldn't have to. It should be quite obvious what our answer is going to be, but we'll see. 113. Okay, hopefully you spotted that before I did. And the next time something's going to happen, it's increased by 8%. Now, that was at the end of year 1. So this is now by 2005. So what we're doing now is we're taking the value of the house now, 113, and we're going to increase its value by 8%. Again, I'm going to use a multiplier. Have a guess, see what you can think. Have a guess to see if you can have an idea what this number is going to be here. By the time I stuttered through that, hopefully you'd got 1.08. Okay, and again, I'm going to use my calculator. So multiply 113 by 1.08, and I've got 122.04. Now, if it was 21% as an increase, then I would expect my house to be £121 at the end, and it's not. It's actually more than that. And that's because the 8% is 8% of this different value here. Okay, so we're not finding another 8% of 100 and adding it on. We're actually finding 8% of 113. And that's where this extra little bits come from. Okay, now it also says calculate the actual percentage increase. Well, we started off at £100. It's now at £122.04. So I'm hoping that you can see that the percentage increase is 22.04%. Now, it didn't tell you that the house was £100, and actually you could have made that any value you like. I chose 100 because I thought it'd make it easy in this particular sort of question. And if it doesn't tell you, and you're doing this sort of a question here, just stick with easy numbers. Don't make life difficult for yourself. Okay, let's have a look at this one then. This says calculate the total compound interest earned on £800 invested for 3 years at 4% per year. Give the interest to the nearest penny. Okay, so what this means, compound interest, again, it means interest on top of the interest. A bit like the last example, where we increase the value over and above what we had the previous year. So here we start off with £800, and we're going to get 4% each year. So we're timesing it by our multiplier, 1.04, and we're going to do that 3 years. So times 1.04 times 1.04. Now, if you've spotted this, you might think, do you know what? Why don't you just change all that to a power? And I will. Let's do this. 1.04 times 1.04 times 1.04 is the same as 1.04 to the power of 3, or cubed. And again, I can type that in on my calculator, and I'm going to get an answer of £899 and 89 pence. £899 and 89p. Now let's just see what it's asking for in the question. I've worked out some maths. It's always worth going back to the question. The question says give the interest to the nearest penny. Now this is the total amount of money I've got in the bank now. So the interest is the bit extra that's been added on, which is £99 and 89p. Okay, this is a final example, and this time we're going to look at this idea of a reverse percentage. So this says Steve sold his flat for £113,400. He made a profit of 35%. Calculate how much Steve paid for his flat. So we don't know how much Steve paid, and I would encourage you to use a letter to say this is how much we're going to start off with. We don't know how much it is, so let's call it X. It was increased by 1.35 or by 35%. It's this increase of 35%. So we've used our percentage multiplier here, and the answer was 113,400. So let's just see what I've done so far. We don't know how much it was to start with. We know though that this unknown was increased by 35%. So here's my multiplier. And the value of his house when he sold it was this price. So to work out what X is, I'm going to divide both sides by 1.35. So divide by 1.35. And I should get that X is, and again I'm going to use my calculator here, 8,400. Okay, so Steve paid £84,000 for his flat. It's not the same as just taking 35% away from 113,400. I'm just going to do that up here just to show and prove a point. If I do 113,400 and if I take 35% away, so if I multiply it by 0.65, that's the same as taking 35% away. 113,400 times 0.65, and this comes out at 73,710. A lot of students will get this as an answer, and it's incorrect. Even though it looks feasible, it's wrong. And again, just to prove a point, if we increase 73,710 by 35%, we don't get back to our original value. 73,710 times 1.35 gives us 99,508. So nowhere near the amount that Steve sold. Percentages you've got to be very careful with. In terms of, it's a percentage of an original amount, not a new amount that you're then reducing. Okay, so take great care on this sort of question. Okay, here's a question for you to have a go at by yourselves. You can pause the video, have a go, and then I'll show you how to do it in a second. Okay, so in this question it says Rudy drops a ball from a height of 120 centimetres. Each time it hits the ground it rebounds 70% of its previous height. Calculate the height of the rebound after it's hit the ground twice. So what's happening here? We started off with 120. We know it's going to be 70% of its previous height. So if we were doing a multiplier, let's think, what can I do that means it ends up being 70% of its previous height? Well, it's being reduced by 30%, or you could say times by 0.7, 70% of its previous height. And it does that twice, so times 0.7 again. Let's do that on our calculator, times 0.7 times 0.7, and we get 58.6. So 58.6 centimetres. Just checking the question, calculate the height of the rebound. Okay, so it doesn't ask us for to round it or anything like that. So we've got an answer and I've typed it in. In fact, it's 58.8. I've just realised I've just misread my calculator. 58.8. Okay. Now it also says that Rudy bought the ball before its price went up by 12%. The price for the ball is now £6.16. How much did he pay? So we don't know how much it was. We know it went up by 12%, so it had a percentage increase of 12%, which means I can use my multiplier, times it by 1.12. It's now 6.16. To work out x, I can divide both sides by 1.12. So 6.16 divided by 1.12. And it tells me that the original price was £5.50p. If you got both of those answers right, well done. If you didn't, just go back, check your errors, see what happened, and make sure that you understand why it's done what it's done. Okay. As ever in these videos, we do a revision card note section at the end, and for percentage change, I would definitely write down, we're going to use a multiplier, and if you're not sure, maybe you could just make a little note that if you multiply something by 1.00, it stays the same. If you multiply by 0 point something, let's say 0.9, it's going to reduce by 10%, and if you multiply by something by 1 point, I don't know, to make something up, 14, it's going to increase by 14%, as an example. Now, repeated percentage changes are not just percentage added together. We saw that from the house question earlier. If it's easier to use powers on a depreciation or a compound interest question, by all means do. And if it's a reverse percentage, don't just take off the percent. You've got to set it out using a little bit of algebra and say x multiplied by whatever the multiplier is. So the multiplier here, multiplier, and that's going to give you the answer. So you're going to end up doing a divide. So the whole point of these is that you're going to end up dividing by the multiplier. Okay, hopefully this has been useful. As ever, if you want to get in touch, then please do so. Good luck with your exams, and I will see you around. Bye.